Hello everyone, myself P.Purushotham, working as Assistant Professor in Department of Computer Science and Engineering, MLR. In this session, I am going to discuss about a thread creation. So, this is the overview of this session. So, first I am going to explain a thread creation techniques, and second I am explaining what a thread creation by using a thread class, and next I will explain thread scheduler, and last I will explain start method and run method difference. Okay, so let's get started today's session now. So coming to thread creation techniques. In Java, we can create a thread in two ways. In Java, we can create a thread in two ways, exactly two ways. The first way is by extending the thread class. The second one is by implementing the runnable interface. So thread is a class. Thread is a class. So that's why we are using what extend keyword. Okay, so that's why we need to use what extending, and runnable is a interface, so that's why we are implementing here. Okay, and thread is a predefined class and runnable is a predefined interfaces, and thread and runnable both are defined in java.lang package. So as we know that the java.lang is a default package, we don't need to import this package. Means if you want to work with the thread and runnable, so we don't need to import any package. Why? Means these are defined inside a java.lang package. Okay, now we'll see the first approach. So how to create a thread by using a thread class, now we'll see. So to create a thread by using a thread class, we need to follow some steps. So first step is we need to create a thread. So we can create a thread by creating child class to the thread class. Means first of all we need to create our own thread, and we need to extend with the thread class. Next step, we should override the run method. Okay, so after creating your own class, you need to override the run method. So let's take an example. I'm taking my own class. Let's take an example, class A. Now the class A is a normal class. Now I want to create a thread, means you must be extend thread class. Now this is the first step. This is the first step. You need to create your own class and you need to extend with the thread class. And second step, you need to override the run method. You need to override the run method. So this is the third step. In third step, you need to define what thread job inside a run method. Okay, so here this part in run method we need to write our own business logic. Okay, thread job we need to define. So thread job we need to define inside a run method. Okay, this is the third step. And in fourth step, we need to call the start method. Okay, we need to create object to the class and we need to start the what method. Okay, so if you call the start method only, the run method will be executed. New thread will be created and run method will be executed. Okay, so these points now I am going to explain the programmatically now. So here I will take my own class as per thread creation step. So first of all you need to create your own class. So let's take an example. Here I am taking class name is a my thread, and I am going to extend with what thread class. So this is the first step. After that, the second step means we need to override the run method. Here I am overriding the run method. This is the second step. And in third step, you need to what? Define your thread job. Okay, now here I am defining my thread job. My thread job is very simple. So I want to print a simple message for 10 times. So here I am writing system.out.println like hello MLR. Now, so this will be what? The thread job. That's it. Now I want to execute this thread job. So what we need to do means, first of all, this thread job is defined in my thread class. So if you want to access this thread job, so first of all you need to create object. Now here I am creating object my thread and t1 dot, and the last step is you need to call what? Start method. Here I am calling the start method, and make sure here compulsory we need to call the start method, then only a new thread will be created and it will automatically invoke what the run method. Okay, now you can see here it will execute hello MLRT for 10 times. So here make sure that, so compulsory we need to call only start method. Why not a run method? Means suppose if you call the run method, it will execute just like a normal method call, but no new thread will be created. Okay, that part I will explain the next slide. So this is the thread creation techniques, and here if you want to create a thread compulsory, you need to call only start method. Okay, here I am creating thread, now it will be executed. Now what is the difference? I will explain the next slide. Now the same example just now I explained. Now here, so suppose assume I have what 2 threads. Assume I have 2 threads. Now if 2 threads are there, now which thread has to be executed? Who will decide? So assume that, let's take an example. Here I have 2 threads, T1 thread and T2 thread. Now the T1 thread and the T2 thread, assume I have the same priority, and which thread has to be executed on the CPU, who will decide? I am starting the 2 threads simultaneously, and which thread will be executed means we cannot predict. So who will decide means the thread scheduler will be decide. So how it will be decided means, here after creating a thread, every thread will be registered in the thread pool. So assume this is the thread pool. Now from this thread pool, which thread has to be executed on the CPU, who will decide means the thread scheduler will be decide. So how it will be decide means, so based on the thread scheduling algorithm, so thread scheduler will be decide. Now you can see here, if the multiple threads are there, then the which thread will get a chance, first execution will be decided by the thread scheduler. The thread scheduler is a program or it is a software. It's a predefined program or it's a software, and it is a part of the JVM. Okay, it is a part of the JVM. So where it is a thread scheduler means it is the part of the JVM. Now JVM is responsible to call this thread scheduler program. Now the thread scheduler will be decide which thread has to be executed on the CPU. Okay, based on the thread scheduling algorithm. Okay, the thread scheduling algorithm may be anything. It may be first come first serve like FCFS or SJF, shortest job first, or round robin, or a priority algorithm, or any other algorithms it may follow, and it may depend on what vendor. Okay, so your operating system vendor, suppose if you are using Windows machine, your output will be changed. Suppose if you are using Linux, so your output will be vary, and run to run, operating system to operating system, and vendor to vendor, your output will be vary, and the output is not fixed here. Okay, so suppose if you take an example, so same point I want to prove now. Now here you can see here I have only one program, sorry, I have only one thread. Now let's take an example. I will create one more thread. Here I will create one more thread. Just I am creating object thread 2. Now you can see I am starting the 2 threads here simultaneously. Thread 1 I started and thread 2 started. Whenever you are calling the start method, what will happen means the start method will be registered your threads in the thread pool. From the thread pool, thread scheduler will be decide which thread has to be executed. Okay, even though if you are starting here and if you are starting T2 later also, these two will be registered in the thread pool first. From the thread pool, the thread scheduler will be decide, okay, which thread has to be executed. Now let's take an example here. So for clear understanding, so hello MLR80, and here I will change, I will call the thread here directly, thread dot, or else directly I will call the current thread dot get name, I will call. So before starting this threads, so first I will set some names. So let's take an example. First thread name is a RAM. First thread name I am customizing, and second thread name I am customizing to what? Sita. Just for your understanding. So here I am customizing my threads. So thread name is what? RAM thread T1, and T2 thread name is a Sita. Now if you execute these 2 threads, now what will happen means, now you can see here the first time RAM got a chance to execute, and RAM got a chance to execute, RAM is executing 2 times, and now Sita got a chance to execute, and Sita got to execute what the 4 times, and again the Ram got a chance to execute, and again the Sita got a chance to execute, again the Ram got a chance to execute, and Sita got a chance to execute, and again the Ram got a chance to execute. Here output will be vary. So suppose if you run this again, there is no guarantee the same output will get. Okay, you can see now the Sita got a chance to execute the first, and the Ram got a chance to execute the first. Sita got a chance to execute first, and it is executing what 10 times, and Ram got a chance to execute, and it is executing 10 times. And again if you run this program, and again there is no guarantee the same output will get. You can see here you are getting what? The different outputs. So why it is happen? Why it is happen means, here you are calling what? T1 dot start and T2 dot start. Now what will happen? So T1 means RAM thread will be registered in the thread pool. So this is what the thread pool. And second thread is a Sita. Now the Sita thread also registered in the thread pool. Now the 2 threads are there in the thread pool. The thread pool is nothing but it is in the waiting state. Waiting state. The state of this threads means waiting state only. Now on CPU, which here we have what the 2 threads, RAM thread is there and Sita thread is there. Now who will decide which thread has to be executed? Now the thread scheduler is the responsible. Now thread scheduler is the responsible. Now sometimes thread scheduler may pick from the thread pool. So suppose assume the RAM got a chance to execute on first, so RAM will be execute, and immediately so RAM will be preempted and Sita got a chance to execute on CPU, and again the Sita is preempted and the RAM got a chance to execute. So means CPU is switch between these 2 threads simultaneously, and that depends on the thread scheduling algorithms, though this switching will be happen. So sometimes RAM got a chance to execute 2 times, sometimes Sita got a chance to execute 4 times, likewise. So it will be execute, and we cannot predict exact output here. This output will be depend on what? Your thread scheduling algorithm and your operating system. Now the differences between a start method and a run method execute, but if you call only the run method, no new thread will be created. So just call just like a normal method call, and no new thread will be created. Okay, so it will treat it as only the main thread. Okay, so if you want, you can see here the same program I am going to explain now. You can see here, now I want to, before starting these 2 threads, so I want to check the number of active threads. So before starting these 2 threads, the number of active threads, so by default the active threads are 2 only. Okay, if you are, for every program the 2 are the active threads. Okay, the one is a main thread and second one is a monitor thread. Now after starting these 2 threads, now here we will get what? The 4 threads. Okay, and you can see here. So initially before starting what the T1 and T2, the number of active threads are what? 2, but after starting T1 and T2, the number of active threads are what? 4. Okay, now you can see. So here apart from what main thread and monitor thread, you have what? Sita thread is there and Rama thread is there. Okay, Sita and Ram. So 2 threads are there, means total 4 threads are executing here. But if you are using only the run method, now what will happen? You can see it will consider only the main thread. You can see here I am calling the run method directly here, I am not calling what? The start method. Now what will happen means it will not consider what? Thread, means no new thread will be created. So before starting the thread count is a 2. You can see all threads are main thread only. You can see here hello main, hello main, hello main, it is executing 20 times, and you can see the number of active threads are 2 only, means no new thread is creating here. When means if you are calling the run method, the no new thread is creating. So if you want to create a new thread, the only way is compulsory we need to create a start method. Okay, if you are not using the start method, no new thread will be created. If you are using the run method, it will call just like a normal method call, but it won't create any separate thread. I hope you got. So this is the main difference between the start method and the run method. And the start method is having some responsibilities here. So what is the responsibilities of the start method? So after creating a thread object, the compulsory we should perform the registration in the thread scheduler. Okay, so as we know that if you are calling the t1.start, if you are calling the t1.start and if you are calling the t2.start, now what will happen means a new thread will be created. Now these threads will be, we need to register in the thread pool. Okay, so to register in the thread pool, now the start method is responsible. Whenever you are calling the start method, automatically, okay, we no need to register manually, automatically start method itself is responsible to register your threads in the thread pool. Okay, so these are the threads and these threads will be registered in the thread pool. Why we need to register into the thread pool means from the thread pool only the thread scheduler will be picked for execution. Okay, now so that is the reason compulsory we need to register every thread in the thread pool. So who is the responsible for that means the start method is responsible. Now the second responsibility of the start method is, so this will take care of the start method and the developer can concentrate on only the thread job. Okay, so here the start method is responsible to register in the thread pool, so that the developer no need to concentrate on what the thread registration manually. Okay, so it will be performed automatically by the start method and the developer can concentrate on only the thread job. And whenever you are using the start method, so automatically it will call the run method also. Okay, and without executing the thread class, there is no chance of start of new thread in Java. The only way to create a new thread, the only way to create a the only way to start a new thread is you need to use only the start method. Compulsory we need to use a start method. Okay, so if you observe the start method, you can see again. So first step, it will register the thread in the thread scheduler or thread pool and it will invoke the run method automatically. Okay, so these are the responsibilities of the start method. So coming to the summary of this session. So in this session, I have explained the thread creation techniques, how many ways we can create a thread, and in this session, I have explained only the thread creating by extending the thread class. In the next session, I am going to explain what creating a thread by implementing runnable interface. And so in this session, I already explained the thread scheduler, what exactly thread scheduler, what is the role of the thread scheduler, and differences between the start method and run method I explained. Okay, so that's about this session. The next session I am going to explain creating a thread by implementing the runnable interface. Okay, so that's all for this session. Thank you.